code. So here's the project, and before we get into the more advanced feature source, I wanted to show you what I call the minimum feature source. And this is the minimal amount of code that actually satisfies the requirement of a feature source. As you can see, there's really not that much here, but we'll go over the main parts and pieces. The first is that it's called the minimum feature source, and it inherits from feature source. Next is that there's only one required overload, and that's as we discussed the get all features core, and it passes in an IEnumerable column names. Now these are the columns that the user wants to return back the column information about. And as you can see inside of here, well, we've kind of condensed it down to one line. You see where we have to return a collection of features. So what we do is we actually create a feature here kind of in line, give it an X and a Y, and we give it its unique ID. We put that into this feature array, and then the feature array goes into the collection and we return it. Now, interestingly enough, this actually works, and if we were to integrate this with a layer and put it inside the map engine and tell it how to render these coordinates, it would render normally, and you wouldn't be able to tell, you wouldn't know that there's only one line of code in here. So let's take a look at the minimum feature layer, and that's going to be the wrapper around the feature source. It's very minimal as well. As you can see, we have called the minimum feature layer. It inherits from feature layer, and in the public constructor, we set this dot feature source equal to our new minimum feature source. So as you can see, really with just 2 lines of code, we've set up the basis of a very simple feature source. Now, this doesn't do very much, but it does prove a point that it really is very simple. Now, let's move on to a little bit more advanced case. We're going to take a look at the OLEDB point feature source first, and we're just going to go down the code. So the first thing you'll notice is that we inherit from feature source. Next, what we're going to find are some private fields, and these are just to store information like the connection string, the table name, the ID column, the X and the Y column, because inside of the database, we actually in this class, we actually built it to where it kind of can adapt to the names in the data source. So if in the Access database our X column wasn't called X, it was called longitude, then we could adapt to that in here. And so here's our constructor, and we have a public constructor that takes no properties, and that really just chains to this constructor. And the information that we need for this particular feature source is the table name in the database, the ID column name, the X column name, the Y column name, and the connection string. If we know that, we can retrieve the data. And so in here, we're just setting the variables that got passed in on the constructor to those private fields. And the next dozen or so lines are just the properties that support the private fields. So if a user happened to call this constructor, then they can set all the properties they need. Next is going to be the open core. And if you remember, this is where we want to initialize or cache our feature source. So what we're doing here is, in the open core, we're creating our OLEDB connection and passing in our SQL string, and then we call the open. So not very much going on there. And if you're wondering, well, what would happen if a user would call this twice? Well, it's not possible, because the user doesn't actually have access to call open core. They only have access to call a method called open. And then we have our own implementation that when they call open, we flip a bit that says that it's open. And if they try to call it again, we're not going to call into your method. And it's the same thing with the close. And as you would have guessed, we take the connection and we close it. So Not really very much going on in here, but it is important. The next bit of code is a little bit long, but we'll deconstruct it piece by piece. And it's the required one, get all features core. And it takes in an array of column names, which are the columns that the user wants you to return with the feature. And what we ultimately have to return is a collection of features. So here's what we're going to do. We set up things outside of our try-catch, like our command and our data reader, and ultimately the collection of the return features. We wrap the insides of this with a try finally, just to make sure that if there are any errors or any problems, that we can always clean up the command and the data reader and all those objects that need to get disposed. So the first thing that we do inside of our try is that we're going to be building up a SQL statement. And as part of that SQL statement, we're going to need to request the columns from SQL that the user requested from us. Because up here, the user's requesting certain columns to come back. So I need to create the select statement so those columns will be returned. So we loop through and we concatenate them with a comma between them. And then here's our SQL command, is that we're going to select the ID column name as TGID. Now, the ID column name, we just, or I'm sorry, this TGID, we just made this, this name up. And the reason that we did is because if someone actually requests the ID from the column names, we want to make sure that there's not a conflict. We select the ID and also the X column as TGX, and the Y column as TGY. And then we put that the column SQL. So if the user requested, like, let's say, the city name would go in there as well. And then from table name, passing in the connection string. So that's our SQL statement. On the next line, we're going to go ahead and execute it. And with that, we get a data reader back. Now, we're going to loop through all the records in the data reader. For each record, we're going to create a feature. And so we basically have created a new feature, and we're grabbing out the TGX and the TGY. And we also put into the feature through its constructor the ID. So each feature is unique. Now what we have to do is we have this feature that has the X and the Y and the ID, but now we need to put the columns in it that the user requested. So we loop through all the columns and column names, and we can say feature.columnValues add, and then we have a key, which is the column name, and then we go to the data reader for that same column name, and we go ahead and add it to the feature column values. And then we add the feature to our result that we're going to pass back. And really that's it. The only thing that's left is the finally, which does a little bit of the cleanup, and the return features. So if I actually went through the code now from here on down and I commented everything out, this would work just fine. Now it might not be optimized, but it would work. So, but before we do something like that, let's go ahead and look at the other methods and what they do. The next one is the get features inside bounding box core. And if you can remember, this was one of those critical methods that I highly recommended that you implement, and we went ahead and implemented it here. Now, what you're going to notice is that a lot of the code is duplicated between the get features inside bounding box and get all features. And maybe if we weren't doing this in a presentation, I would have broken some of these out into their own private methods. The reason I didn't do that is because it's a little bit easier to follow if you just have one long method without having to jump around into different sub-methods. So in this particular method, it's going to pass in a bounding box, which is a rectangle shape, and it's going to pass in the returning column names, just like the get all features did. So as we did before, we set up our command and data reader, and we get our return features ready to go. We've also wrapped this in a try. We do the exact same thing with getting the columns that we're going to want to return from the SQL. The difference here is that we have a slightly different, or actually we have a where clause, where in the get all features we didn't have a where clause. And now the where clause is not very complicated, but it is somewhat complicated, because what we want to do now is we want to take the bounding box and we want to make sure that these points are in it. So to do that, you have to say something like where the x column is less than or equal to the bounding box dot lower right point dot x. And you have to compare the bounding box upper left and lower right, x and y, to your point. And so I'm not going to go into this whole thing, but you can take a look at it at your leisure. But this SQL statement will work for any point-based kind of layer that's in SQL. So it's a little long, but it does work. So then we have our SQL, our select statement like before, and we select the ID, the X, and the Y, just like we were doing before, from the table name, where, and then we put our where statement. Now, it's comparing the X and Y's in the databases. So one important thing is that if you have a very large database filled with these X and Y values, it's a really good idea to put an index on those two columns. It'll be able to much more quickly find the result, especially for large, large tables. We go ahead and execute our data reader, and then really from then on, everything is exactly the same. We're going to loop through our data reader, we're going to create our feature, we're going to populate the column values, we're going to clean up and return. So really the only difference is just adding this extra where clause. So it's usually not that big of a deal. Okay, let's keep going down. What we're going to do here is we're going to do a select statement, select star from the table name where 1 equals 2. Now, where 1 equals 2, that's guaranteed to never return any rows, but it can return nothing back very, very quickly. And from that nothing result, you can actually take a look at the table schema, because that's returned even if no rows are returned. So we go ahead and execute that reader, and then we're going to loop through the data reader.field count, and we're going to construct these feature source columns, and the only requirement of a feature source column is that we're going to get the name. So we're looping through the columns and we're adding the names. And then we do our cleanup and we return. And that's really all you need to do, because once you've done this, then the user can request those columns, and in the get all features and get features inside a bounding box, we'll tack those column names onto the select statement, and they'll be returned. The last one of the recommended methods is the get count core. What we're going to do here is we're going to set up a command, and inside of our try, we're going to do a select statement where we select the count from the table name. And then here we execute the scalar request, and we get the count back. We clean up, and we return the count. So as you can see, this is much more efficient than our default implementation, which would be to call the get all features core and then count all the records down. Now that you have an idea of how we've implemented this, let's jump into our sample and just quickly review what the sample code looks like and how we're going to use it. So here's our sample form, and if you've written some map suite code before, this is going to look really familiar to you. If you haven't, then we're only going to go over this fairly quickly, due to time constraints. But I highly recommend that you download an evaluation, you look at the samples, and try to write some samples of your own. So the first couple of lines are basically setting the map engine extent and selecting a fill brush. So we're going to have a nice blue background. The next is pretty important for what we're doing, because this is our cities layer, our OLE DB point feature source. And as you can see here, we have a connection string. It uses a Microsoft Jet provider, and we're passing in the location, a relative path to our cities database.